Hello lovely people, what is up? Today we are solving Leetcode problem number 67 at binary, which is marked as an easy problem, so let's get right to it. So what we are given two binary strings A and B, and then we are asked to return their sum as a binary string. So let's take a look at this example that they've given here to better understand what they're asking. So here the numbers are 11. Oh, let me change it to marker. Yep, this one. So it's like 11 and 1. So these are in binary form. So when we convert it, you can see that this number would be 3 and this number would be 1. And then when we add it, we get 4. That is the output. 4 is written as 100 in binary. So another way we can solve this without converting it into its respective decimal value is by adding these. So when there are two ones that we have to add, it becomes 1 0 because 1 plus 1 is 2 and the binary representation of 2 is 1 0. So what we do here is we write 0 here and carry it over to here. So again it is 1 and 1, which is 1 0. We add 0 here and then carry over 1. Since there are zeros here, it will be 1 0 0. So now let us take a look at this second example because it covers another case that we have not seen till now. So here the numbers given are 1 0 1 0 and 1 0 1 1. So here 0 and 1 is 1, so no carry. So no carry. Okay, what is happening? And then 1 and 1 is 2, which is 1 and 0. So 0 is here, 1 goes here, and then it is 1 here, and then here it is 1 and 0. So we got the answer here. So what happens if we had to carry over a 1 here? So for example, let's take both of these. Instead of zeros, they were 1. So what would have happened here? Here 1, carry over 1, so there are 3 ones here. How do we represent 3 in binary? 1 and 1. So here we'll have 1 and then we'll have to carry it over to here. So how can we think about it is, first we add these two ones and then we add 0 here. I'm sorry, I meant 1. We add 1 and then we carry over another 1. So the answer would look like this. So now that we have the basic understanding of the intuition, let's take a look at how we are going to write the code. So basically what we're going to do is we start from the rightmost digit, that is the least significant bit, and we add bit by bit with a carry. And then finally we build the answer as a string because we note that in the question they've asked us to return the answer in the form of a string. So now let's take a look at the code. So first we initialize a variable result to store the final binary answer, and then we initialize the carry variable which stores carry from the previous addition. Now to reverse both strings, we start from the least significant bit, so we are using bit slicing, which will be a bit and b bit, and we are slicing it like a colon colon minus 1 and b colon colon minus 1. And then we start to loop through the longest length using a for loop. Since we're looping through the string with respect to its index values, we are using for I in range of maximum of length of a comma length of b, since we need the maximum string length out of the both. So we can add zeros to the most significant bit in the smaller length string or the number. So after that, to get digit from a or 0 if out of bounds, we define an if statement stating if I is smaller than length of a, then the digit a, that is the value of a, will be the present value in the given index. And then we do the same for b. Why are we setting the missing digits to 0? Because mathematically nothing plus 1 is equal to 1. So treating missing positions as 0 keeps our logic clean. And then we are converting the characters to numbers. That is why we are using odd. But to perform that, we are using odd, because ASCII of 0 is equal to 48 and ASCII of 1 is equal to 49. So 48 minus 49 minus 48 is 1, and 48 minus 48 is 1. ORD is a function that returns the numeric Unicode, that is ASCII value of a character. So essentially what we are doing is we are getting the digit from A or B, and if there is nothing, we add 0, because 0 we are adding when it goes out of bound, that is there is no such value. We are doing the same for A and B. So that is the reason for the if and else condition for both length of A and length of B. Then we calculate the total by adding the digit value of A and digit value of B, and then adding the carry. And then we update the results, like we are type converting it to string. So that is why string of total by 2, and then we are adding result to the total. And finally, we are updating the carry as total flow divided by 2. So if any carry remains, we do add 1 plus the result, because if, like we saw in the example, if there is 1 carry left, we just add it as the most significant bit. That is what is happening here. So in the previous step, to update carry, why are we flow dividing total by 2? Because when the total is any value other than 0, when we flow divide it, the carry becomes a proper value that is required on that particular step. For example, if there is 0 and we flow divided by 2, carry becomes 0. If it is 1 and we flow divide by 2, the carry is still 0. But when it comes to 2 and 3, the carry becomes 1. This is so as to match the binary rules. And finally, we return the result, the variable or the value that is stored in the result. So as you can see, this runs in the most optimal time complexity. The time complexity is O of n, and the space complexity is also O of n. Since we are iterating through the length of only the longest string that is given, either A or B, the time complexity becomes O of n. So that is all for today. Hope you guys enjoyed today's video. See you in the next one. Bye bye.